and figure out what pairing is produced. So let's see. I'm gonna have a table for men and also a table for women. Okay, so we have 3 men, 1, 2, and 3. We also have 3 women, A, B, and C. So on the first day, each man proposes to the first woman on his preference list, right? So man 1 would propose to A, right? Man 2 would propose to A again, because A is the first on the preference list of man 2. And man 3 would also propose to C. Okay. Now looking on the women's side, woman A has 2 proposals from 1 and 2, right? Woman B has no proposals yet, and woman C has 1 proposal from 3. Okay, so now it's the job of women to reject all but the best proposals they have. Okay, so C would obviously not reject 3 because that's the only proposal she has. B cannot reject anything at all because she doesn't have any proposals yet. A has to choose between 1 and 2. Which one is she gonna choose? Well, the one that's on the top in her preference list. So if you look at A's preference list here, 1 is bigger than 2, so 2 is going to be rejected by A, right? Okay, so that's what happens on day 1. Now on day 2, 2 got rejected from A, right? So he goes to his next choice, which is B, right? So 2 proposes to B. Now what happens on the women's side? Well, A still has her proposal from last day, which is from 1. C also has her proposal from last day, which is from 3. Now B has a proposal from 2. Now as you can see, all of the proposals are to different women, and each woman has exactly 1 proposal. So this is the point where the algorithm finishes. So the algorithm finishes on day 2, and the pairing produced is 1 and A, 2 and B, and 3 and C.